on, we are going to go back to go forward. So what I want to do is review what we did yesterday. So I need you guys to get in your, first of all, before we get started, everybody understand we're going to have an activity at the end of this class where you're going to be working with teams. This is a 3-team activity. So I see people missing. I see some people missing. What I want you guys to do before we get started, get your head straight. You have this class, let me put you in groups of 3, all right? So you guys over here, it's going to be a group of 3. You don't actually, all you have to do is be able to see each other well. So I'm going to do these 3, so 1, 2, and Olivia, who has stepped out for a second, will be your 3rd person. All you got to do is be able to see each other. That's it. You don't have to move. So right here, I've got, let's do 1, 2, and 3. Okay, so you just have to see each other. 1, 2, and 3. This person. Okay, and then let's do 1, 2, 3, and 1, 2, 3. So you guys are actually, all you have to do is be able to see what you have and be able to show each other your cards. That's all you have to do, all right? So let's get moving. So yesterday we talked about the difference between atoms, pure molecules, and compounds. So what I'd like for you guys to do is go ahead and write the date on your folder. Write 10-1 on your folder, please. And you guys are going to draw 3 boxes. So the boxes need to be approximately 3 lines long. So if you will draw a box right now that is 1, 2, and 3, and just spread those across the top of the paper. And I want you guys to draw bubbles in the first box that are separated like this. Okay? Now, I asked you guys yesterday, how do you differentiate, meaning what's the difference between, we use the word contrast a lot too, how can you contrast or differentiate between atoms and molecules? Atoms and a pure molecule. What's the difference between just atoms and molecule, Ilani?
Atoms are by themselves and molecules are clumps of atoms.
Okay, she said atoms are by themselves and molecules are clumps. I love that word because it gives us a visual. That's a good word. Can somebody use the B word? Bonded. Thank you. Bonded. Well done. So they are bonded. So you guys, would these be just atoms or is this a molecule?
Atoms.
Atoms. Can you write underneath here? Atoms. You're going to go ahead and label it up. Let me get a marker. All right. Lovely color. Oh, that's not bad. Okay, atoms. So in that case, you guys, this would be a what?
Molecule.
Woo! All right, so you guys, I'm going to write pure molecule. Can you actually use the word pure molecule? And we talked about pure chocolate. Pure chocolate. So what I need you guys to do, we're going to do some more contrast or differentiating, find the difference between, right? So I want you to tell me the difference between a pure molecule and something called a compound. Okay, Jonas.
A pure molecule is just that thing. A compound is a variety of atoms, I suppose.
Okay, I love the way he said a variety of atoms. Good. So what he's saying, what I believe you're saying, is that a pure molecule, if it's just that one element clumped together, those atoms, they all match. And then if it was a compound, that's going to be like 2 or more types of elements clumped together. So would this be a pure molecule, and what would this be? Compound, absolutely. So everybody write compound, please, underneath this. This is just a quick throwback. So since we're talking about atoms, let's go way back. So you guys, how many atoms did we talk about that we were, natural atoms that we were going to try to manage, Gavin?
92.
92 it was. So here, I have a task for you guys. I need you guys to, we're going to start with hydrogen, and I want you guys to say them out loud in order, all 92. Nope, I'm sorry, you have to look at me and say it.
Oh.
So you guys ready?
No.
You have them memorized, right?
No.
Yes, we don't, because they're 92. I don't have them memorized either. Nobody can do that. Thank goodness we have a tool. What is the tool that you guys use? Periodic table. Woo, for the periodic table. So the periodic table is organized into 3 main sections. Somebody talk to me. What 3 sections? Go.
Metal, metalloids, and non-metals.
Everybody agree?
Yes.
Yes. What's the largest group?
Metals.
Metals. Okay, so metals are even organized inside them. And 92, that would be a lot. Thank goodness for the tool. But let's talk about compounds, because that's where we're heading today. Compounds, you guys, Joab, can you pay attention, sir? We can't talk.
I was switching.
Okay, we can't both talk at the same time. Okay, so the 92 elements can be, Skylar, they can be organized in any grouping you want, and you can do as many numbers as you want. That creates an unlimited number of compounds. So if we had struggle with 92, what in the world are we going to do with it? We have reviewed. So I want you guys, we're going to move forward. Since we're talking about compounds, and now we know that at Walmart there's an unlimited number of compounds, and we could never keep those things organized without a tool. We're going to talk about how we would organize compounds. So we said the periodic table was a tool for atoms, but now we need a new tool because compounds are not atoms and there's so many more. So you guys, I want you to title. This is your new notes for the day. So if you will draw a box, you know how we do a title, it's a box. So put a box on your page, and you guys are going to write for your title for today, classifying compounds. Classifying compounds. So ladies and gentlemen, compounds they're unlike periodic table where there's three main categories. Compounds have only two. So I need you guys to write two. Compounds are, the first one that you guys haven't heard yet is acids and bases. So compounds and bases. Compounds have to have a tool. So they are organized on a tool called the pH scale. Now it's written funny, so I need everybody to write a small p and a capital H, that's not normal. The H stands for hydrogen, and that's a whole other lesson that's outside of the scope of what you need to know. But I will tell you, since we talked about hydrogen before, the H is for hydrogen. So the pH and scale. So you guys, a scale is sliding. We can slide up or down on the scale, but what you need to know is the parameters or the boundaries of the scale. So this pH scale goes from, and I want you guys to mark in your notes, 0 to 14. So sometimes we say 1 to 14, but you know, I've looked at it and I think we need to use 0. So yeah, I need you to add in 0 to 14. So the problem is, we could say 1 to 14, but some items, when you test it, it comes in at like a 0.5. Well, that's less than 1, so we need to count the 0, so I needed to change that. So low numbers. All right, if I tell you you have Bernie acids and you have bases, in your common sense, what would you probably think the acids, probably from your common sense?
High.
High numbers would be common sense, right? Because I'm thinking the more it burns, the higher it must be, right? So the only way I can remember is it's backwards to what you think. The low numbers on the scale are acids. So if you guys will write this bullet point right now, and this is a great time to use color in your notes because it's easy to, you know, keep track. So you should be putting the asterisks on the side because we want to practice good organizational skills. And you can leave, you know, a line if you want to, but spread this information, make it nice. So if the low numbers are acids, the high numbers are bases. It's just like compounds. She's right. They're all compounds. So the high numbers are bases. All right, so when we were talking about protons and electrons, protons being positive, electrons being negative, you guys said there was one that wasn't really either. So if you're not really either, we said they were neutrons. So if you're 7, yep, that's a good vocab word. 7-ish on the scale means you're, what's the, it's like not really
You're
either.
in the middle.
It's not there, but it's there.
Yeah, it's there, right, but it's not acid, it's not base. So we're going to call it neutral. So I need you guys to write this word. Neutral. 7-ish, that is neutral. Okay. So if you have all those notes done, can you give me one tap on your desk and one on? Excellent. So I need you guys to look in your book very quickly. We never hardly use the book. We're not big book users, but I need you guys to look at a picture of a pH scale. So I believe it is 487. Because you want to see what you're going to be dealing with. Is it? Okay, so 487. So look at 487. We're going to just look at it quickly. Yes, ma'am. Was that it? Oh, you didn't get a book? There you go. Thank you for sharing back there. Appreciate it. Okay, so you guys see how this scale goes up and down, these arrows, right? So the way we're going to do it is a different way. We're going to turn it sideways. So everybody spin your book, and so it's going left to right. We're going to use it that way. I think that's much easier. Oh, and by the way, put the 0 on your left. So that means I'm going to turn my book the other way. So red should be on your left.
So upside down.
Yeah, I had to turn mine the wrong way, exactly.
Why
So,
are the acids like that?
Thank you. All right, so here we go. So you guys, we're going to apply what we're learning. I need you to actually add this. So everybody, normally I tell you, hey, let's just flow and go in your folder. Today I need you to move to a whole new sheet. So you guys are going to take the next blank sheet, if it's the back or the front, I don't care. And then you're going to turn that blank sheet sideways landscape because we want to go left to right. So spin your folder so that you have a nice long marking area. So I need you guys to kind of somewhere in the middle of the page, I want you to pick one blue line that you're going to draw across, and don't go all the way, but get close. So you're going to go on a blue line, and I want you to follow the blue line with your pencil all the way across. Very good. Almost to the very end, but leave a little gap on the sides. And then you're going to skip a line, skip a blue line. And then on the next line down. So you're only going to skip one blue line, and you're going to do it again. Yeah, you're drawing like an arrow. So once you get here, you guys draw an outward line from both of these like that, and that becomes a point for your arrow. Same thing here, up and down. You're going to draw. So I think that it helps us a lot when we can talk about it all day, but it helps so much to do. So I need you guys so remember our scale runs from 0 to 14. So on one far end, almost where the arrow starts, I need you to add a 0. And on the other side, you know the scale runs, we said to what number?
14.
14. So let's add right here, 1, 4, 14.
Oh, it's hot.
It is high. We're going to make it. So somewhere in the middle, I need you guys to determine, Shane, take your finger. You have everything I have. Yes, sir? Yeah. Okay, so I need you to stay on target. So,
working on it.
thank you, ma'am. So right in the center, right dead center, I need you to figure out where the middle is. Put your finger there, and you're going to put a 7 right in the center. And you're going to make it nice and pretty, because this is like your periodic table. You're going to use this tool many times in this unit. So we want a nice tool.
Okay, we're running with the Amy.
All right, so now that you have that, I want you to use this first gap. Figure out approximately where his middle is. Put your finger there. And you're missing 1, 2, 3, and 4, 5, 6. So I need you guys, don't add numbers yet. In the center, split this middle. Put 3 on one side and 4 on the other of where you think center is. And this is going to help you make a beautiful, even. So once you get the 3 and the 4 in the middle, now it's really easy to equally distribute your 5 and 6, and you'll be pleased with the way this spreads out. Everybody good? Woo-hoo. Next one, go to the center. You're missing 8, 9, 10, and 11. So 10 and 11 should be in the middle. Put your finger in the middle. On one side of your finger, put the 10. On the other side, put the 11. And now it's easy to even them out. You're missing 8, 9. Well, I can equally distribute my 8 and my 9, and I'm going to like my tool I'm drawing here. 12, 13. Woo-hoo! Okay, so what are the low numbers? I got acids, bases, and neutral. You tell me what the low number was? Acids. So above it, can you guys write acids? Nice capital bit letters, make it look beautiful. And on the other side, the high numbers are?
Bases.
Bases. Let's write them in. Woo-hoo. I like it. So what am I going to write above 7? It's neither. Neutral. So we're going to put right above the 7, let's add the word neutral. Neutral.
Imagine I know you saw that.
It's so beautiful. So if you have that drawn and you're with me, can you tap? It is time to investigate and find your own compounds and pH. Now this is when it gets fun. So you guys, everybody, I'm going to go around and give you guys some letters. You are A, B, C, D, E, F. A, B, C, D, E, F. Hey, Zion. E, F. A, B, C, D, 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 E, F. A, B. Everybody got yours? Now watch this. I'm assuming that I was an AB, so I need you to take your pen or pencil, and on the tip of your, please, I had a kid last period who wrote it in the middle and it wouldn't work. You have to write the letters on the edge, the end of your strips now, please. Whatever your letters are. One on each one. Okay, on either side of this room are 6 compounds. They're labeled A, B, C, D, E, and F. So you have 2 strips. You're going to go to the correct compound. Like if I'm holding, Shane, if you can pay attention to me, I would appreciate it. So if I have this A, I would walk to substance A, and I'm going to hold it by the letter, because I don't want the ink in this, you know what I mean, because ink is a compound too, right? So it'll mess up your color. So you're going to hold it, and you're going to dip it in, slosh it around, okay? And then you're going to take it, do the second one, and bring them both and put them back on your paper towel. You guys good? You understand? They are going to change color. And I want you to just lay them there and watch them change color. All right? So, yeah, it's fun. So here we go. If you're on this side of the room and you're an AB, if you're an AB, go now on this side of the room. Any ABs, get up on this side of the room and go. If you're a AB here in the middle, go to that side of the room. ABs, go to that side of the room and dip your strips. You guys over here, if you're a CD, go ahead and dip your strips. The one with this says A on it and B. They're labeled, you guys. They should be labeled. Hey, whoever has baking soda, could you stir it a little bit? All right. So let's do the EF. So if you're an EF over here, go ahead and dip your strip. If you have baking soda, can you stir for me, Gavin? Can you just stir that baking soda? Thank you. Whatever the letter is. So if you have EF, you're going to see it labeled E and F, and only dip it in that. So everybody who's left in the middle, who hasn't gone, go to this side. So you guys are going to dip it and go back to your seat quickly because we're short on time and long on task.
It's orange. What's that?
Turning color, huh? That's awesome.
Wait, Miss, do CD go over
Doesn't
there?
make me happy.
And there's CD over there too. So whatever you're closest to, so go ahead and get in. You guys, as soon as you get, go back to your seat.
So apparently apple.
If you have bleach, some of you all have bleach, be very careful. And I need you to go back to your seat as soon as you did that.
Miss Millard.
Yes.
Apparently applesauce is more acidic than bleach.
I would agree. I would totally agree. Applesauce is more acidic than bleach.
Miss, what did you say?
Very interesting, right? Okay, so have a seat, Joab. If you'll sit down as soon as everyone can get back, that's excellent. Because you have bleach? You have bleach? Okay. No, go sit on your desk. That would be a real waste of time if you threw it away.
That's fine.
I know. Okay, hurry up, everybody back to your seat. Okay, ladies and gentlemen, you have your chart. You have your chart. Right. So we colored the chart. We know the colors that we're dealing with. So you guys, we know that anything that is super red, goes on the chart as a acid. All right, so who has something that's red, that turned red?
Me.
Excellent. What do you have?
I have D.
Well, what was D?
D was
D. So anybody else have D? What was lemon? What was it? Was it lemon juice?
Juice.
Okay.
Oh no, C was lemon juice. D turned green, C turned orange.
Okay. All right.
But mine says D.
Yeah,
Did you
put
dip
it
it in
on.
D? Okay. So